Now let's take a look at how to calculate slope given 2 points. We have a formula for that. If you have 2 points, let's call them x1, y1, and x2, y2. All of that in my pen won't write. There we go. You plug it in your slope formula. Slope formula says y2 minus y1 divided by x2 minus x1. Now I use the different colors because everything in dark blue you have zero control over. The only things you get to play with are the numbers in a color. I'm going to start on the first one by identifying my pieces. So I have the x-coordinate for my first point and the x-coordinate for my second point, the y-coordinate for my first point, and the y-coordinate for my second point. Now sometimes this is when I get asked the question, Ms. Graham, does it really matter which order I do them in? Absolutely not. If you wanted to make the 6-9 point number 1, you could. It's totally your choice, but we'll all end up in exactly the same place in the end. Now, you all know by now that I'm a big believer in WTF. We're going to write the formula before we do anything else. y2 minus y1, x2 and x1. Notice all of the y's are on the top, all of the x's are on the bottom. If you mix them up, if you do an x and a y and an x and a y, you are not going to end up in the same location. My y2 is 9. My y1 is 0. x2 is 6. x1 is 3. Now at this point you could go to Desmos and plug it in. This is fairly simple math, so I'm just going to do it like it is. 9 minus 0 is 9. 6 minus 3 is 3. And I'm going to reduce this to 3 for the slope of our line. Now let's look at the second one. This one has some negatives in it, but that's okay. I'm going to identify my pieces first. The x1 and x2, y1 and y2. Then I'm going to WTF. I'm going to write the formula. Then I plug in what I know. I'm going to go ahead and set up holes for me to plug stuff in, and I'll tell you why in a minute. Y2 is a negative 2. Y1 is a 6. X2 is negative 2. X1 is negative 5. And this is a perfect example of why I put in the parentheses. Right here. The minus negative 5 is where a lot of my students make mistakes. They will actually leave out one of the negatives or one of the subtraction symbols because there's one in the formula and they think that counts for both, I guess. Please, 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 please make sure that when you are plugging in a negative number, you keep its negative and you keep the one that's already in the formula. You don't get to get rid of those. -2 minus 6 is -8. -2 minus -5 becomes -2 plus 5, and that's 3. A negative divided by a positive is a negative, and I can't reduce 8 over 3. So I'm going to leave it my slope as -8 over 3. Now, if you are not good with your positive and negative numbers, this is not the time to be a hero. Plug this into Desmos if you need it to get your signs right. Now, right off the bat, I notice something about the 4, 6 and the 4, -2. I notice that my x values match. That means that when I plug in to the slope formula, I'm going to get a 0 in the denominator. It doesn't matter what's in the numerator at this point because any number divided by 0 is undefined. It doesn't matter what the y's are. We don't care. You have an undefined slope when there's a 0 in the denominator. Now, if that bothers you and you really want to complete the top part, we will. We would have -2 minus 6. That's -8. -8 divided by 0 is undefined. If you forget, you can put -8 over 0 into Desmos, and it'll tell you that it's undefined. On this last example, this time I noticed that the y's match. That means when I plug the numbers into the formula, I'm going to have a 5 minus 5 in the numerator. 0 divided by any number is just 0. Quick review. 0 slope means we have a horizontal line. So without even having to look at the x's, it doesn't matter what numbers I get for the x's, my slope is going to be 0. But again, if it really bothers you that we didn't finish the bottom part of it, we can plug it in. It would be 6 minus -3. There's my parentheses again because I don't want to drop a negative. This would be 6 plus 3, and our result is still 0. Just remember, undefined slope. Creates a vertical line. Now let's look at an application problem. Because it's great to work these things just finding slope of line all day, but unless you can actually apply it to the real world, it doesn't do you a whole lot of good. So according to the U.S. Census data, the population of Houston in 1980 was 1,595,138 people. In 2020, the population was 2,304,580 people. Calculate the rate of change for the population of Houston from 1980 to 2020. We're going to indicate whether it was an increase or a decrease based on the sign of your answer. Well, y'all, I just read this problem. You heard me read it out loud. I see 0 things in here. The word slope is nowhere in this problem. I'm even wearing my glasses, and the word slope is not in there. But we have this phrase right here, the rate of change. rate of change means slope. That means y2 minus y1 over x2 minus x1. So that's what we're going to do. The other thing you might notice is that before we were given 2 points. We don't have any points. There's no parentheses and commas and giving me an x and a y. We have to go find those. And sometimes you have to pair up pieces of information to make that happen. Right here, I have a year and a population. So I would have 1980 and 1,595,138. That is real data. I did actually look it up. So if you don't believe me, you can go look at the census data yourself. Then I have another set of data right here with a year and a population. So my next point is going to be 2020 and 2,304,580. Well, now I have an x and a y and an x and a y. So when I fill in my slope formula, I'll make this longer because I got some big numbers here. I need y2 minus y1 divided by x2 minus x1. Well, this is definitely a Desmos moment. I'm going to open it up on my desktop. This gives me 709,442 over 40. When I plug it in, I get 17,736.05, and this is people per year. If I were actually going to do this, I wouldn't worry about that 0.05. That's not a whole lot of a person. I would round this to 17,736 people per year. This last one is asking for rate of change for the median home price. Median home price is the home price right in the middle. Again, I need 2 points. I've got 1980 and 55,000. And then I have 2020 and 268,000. And we're going to figure out the rate of change for the median home price. Still going to use my slope formula. Y2 minus y1 over x2 minus x1. And I am not going to be a hero and attempt to do this in my head, because if I do that, I am going to get it wrong. This is 213,000 over 40. So this is $5,325 per year for the rate of change for my median home price. So each year, so from 1980 to 1981, it went up $5,325. In the next year, it went up by the same amount. So that is a quick look at slope and some of its applications. If you have questions, feel free to send them in the direction of your professor.